Hi everyone, welcome back to Science 9. This week we're going to go over our last lesson for electricity. So far we've covered the big ideas: how electric current is the flow of electric charge, how voltage, current, and resistance are all related, and some electrical safety stuff. Last week we went over the basic parts of a circuit, and this week we're going to go over the different types of circuits. So this week, we're still going to do some Ohm's law calculations with these series and parallel circuits. So we'll cover the first three things. And then our main focus is going to be the types of circuits here. So the difference between series and parallel circuits. So just to review, remember the basic parts of a circuit. It needs a source of electricity, so like a battery. It needs conducting wires, and it needs something that slows down the flow of electricity and converts it into something else. And remember all these things here. So the source, the conductor, the load or resistor, and the switch, which switches are optional, but they're pretty important, can be represented by these symbols in circuit diagrams here. And remember the basics of Ohm's law. So symbol for volts is V, symbol for current is I, and symbol for resistance is R. And those are all related, and you could figure out voltage, current, or resistance if you know the other two by using either one of these formulas or the Ohm's law triangle. And we're going to be using this circuit construction kit, the circuit simulator from PhET, again this week. So to start with, and this is the only real part we're going to spend on short circuits. What a short circuit is, it's what happens when the electrons, instead of taking the full path from the battery through the wires, through the load, and then back to the battery, is if the circuit gets shorter, kind of where the name comes from. So if there's two wires that are frayed and they're overlapping and the electrons can just go from this wire just back to the battery, that'll cause a short circuit. You guys are probably most familiar with short circuits with water, and if you drop your phone in water and it stops working, that's because water is a good conductor. So instead of the electrons traveling along the path they're designed to travel on your phone, they'll take a little shortcut and then they'll potentially destroy your phone. But what we're going to spend most of our time covering this week are series and parallel circuits. So series circuits are when there's more than one, say, light bulb in a row. So electrons leave the battery, they flow through one light bulb, flow through more light bulbs, and they eventually return to the other side of the battery. So that's series. These are more, these are older circuits. You might hear stories of your parents telling you when they were kids and they would put up their Christmas tree or their Christmas lights. If one light was burnt out, then none of the lights worked. And that's because they used to be a series circuit. Parallel circuits are different. So the wires leave the battery and the electrons flow on these wires, but there's multiple pathways. So these ones right here, there's three light bulbs and they're in parallel. So that means that if one of these light bulbs burned out, the electrons would still be able to flow through the other two light bulbs and back to the battery. So these are the more modern circuits, parallel circuits. So just a little more information on both of these. Series circuits, there's only a single pathway for the current to flow. The current is the same everywhere in the series circuit. And like I just mentioned, if one bulb goes out, then the whole thing stops working. All the voltage gets used up from the battery between the start of the circuit and the end of the circuit. So there's only one light bulb in this series circuit, then it'll use all 10 volts of the battery. If there's more than one light bulb, then they have to share those 10 volts. So the voltage used up by each light bulb, or what's also called the voltage drop, that equals the total voltage of the battery. They don't have to be the same as well. So in this example, they both use 5, but this one might use 6, this one might use 4. It's just an example here. But basically all the voltage drops add up to the total voltage of the battery. So that's why, and we'll see this using the circuit simulator, if you have 2 light bulbs that are in series, or if you have one light bulb and you add a second one, because say this one was using the full 10 volts of the battery, if we add a second light bulb in, the first one will be dimmer. They'll both be dimmer because less total voltage is used on each light bulb. So just to kind of sum that up, when you add a second light bulb in series, the total voltage of the circuit stays the same, the voltage put out by the battery, but the voltage used on each light bulb goes down. The total resistance of the circuit goes up because now there's resistance coming from more than one light bulb, but the resistance of each light bulb doesn't change. And finally, the current of the circuit goes down because of Ohm's law. So the voltage stays the same, resistance goes up, current goes down. So before we get into some practice problems, I'm just going to show you an example here on this FET construction kit. So building our circuit, put a light bulb in. So this is flowing here. We know the voltage of the battery is 9 volts. I'm going to click this show values. We're going to make it 10 volts just to make the math a little easier. And we'll look at the current here. Current's 1 amp. So we have 10 volts, 10 ohms of resistance, and the current is 1 amp. Now, if I add a second light bulb, that's also 10 ohms. If we look here, these little lines here, there's less voltage used on each of these, and the current went down. You guys see that? So same voltage, same resistance, but both bulbs got dimmer and the current went down. So we're going to do some practice problems. So how I've set this up is I put the problem on this first slide. So I'd like you guys to try to figure this out, and then I have the answers on the next slide. So the first one here, if one light bulb uses 5 volts, second light bulb in the series uses 10 volts, how many volts does the battery produce? The answer is 15. Sorry, these first couple questions, I didn't put the answers in the second slide. Okay, second one, if the battery gives off 25 volts and one light bulb uses 5 volts, how many volts does the second light bulb use? So pause here. And here's the answer. So the second light bulb uses 20 volts. Third one right here. So the current for this circuit is 10 amps. The first bulb has a resistance of 10 ohms. The second bulb has a resistance of 15 ohms. Calculate the total voltage. So we could do this one of two ways. We could say the voltage used by the first light bulb is the resistance times the current. So 10 ohms times 10 amps is 100 volts. And we could say the voltage used by the second bulb is the current times resistance. So 10 amps times 15 ohms, so 150 volts. and we could add those two up as 250 volts. And let's just try that out with the circuit simulator here. So the second light bulb is 15 ohms and the first one is 10 ohms. So we're going to change this to 15. We're going to change the voltage on the battery. Oh, we can only go to 120 volts. We'll add a second battery here. We need to add these up to 250 volts, and we'll add a third battery that is 10 volts. Okay, so we have 250 volts total. This is a resistance. The current is 10 amps, and if we look at it, that matches. The current is 10 amps. We could do this question another way. So the second way we could do this is we could just add up the total resistance. So this circuit has a resistance of 25 ohms. And then to calculate the total voltage, we would go the current times the resistance. So 10 times 25, which is 250 volts. So we could get the same answer different ways. Okay, here's another question. If each light bulb has a resistance of 5 ohms and the voltage of the battery is 50 volts, what is the current? So pause here. Okay, let's check our answers. So we know that the total resistance is 10 ohms. To figure out the current, we go the voltage divided by the resistance. So we go 50 divided by 10, and that's 5 amps. And we are just going to test that out right here. We'll get rid of this. Get rid of these two. We see that there's 50 volts, and each of these is 5 ohms. Change the battery to 50 volts. And we'll check the current is 5 amps. And that's what we got. Okay, now a question. If a third light bulb with a resistance of 5 ohms is added in series, what's the current now? So still 50 volts. So pause here. So now we see the total resistance is 15 ohms, 5 plus 5 plus 5. So to figure out the current, we go V divided by R. So 50 divided by 15, and that's 3.3 amps. And we're just gonna double check to see if this matches what we got here. Put that back to 5. And it matches. We have 3.3 amps. So I have a series of extending questions for you. I'm not going to go over them, but if you found that somewhat easy and you want a bigger challenge, here are some of them. So I'll just get you to pause the video before the answer is provided. So I'll give you a second to read this over. Pause here. And here's the answer. Okay, another question, pause here. Here's the answer. Another question, pause here. Here's the answer. Okay, one more. And here's the answer. Okay, so stay tuned for the second video on parallel circuits.